Welcome students to the fifth lecture of Logic and Distributed Control System. Today we are going to discuss about the programmable logic controller. So as an introduction, we want to know that what is sequence and logic control. Many control applications do not involve analog process variables. In your course like process control engineering, you have studied the analog controllers like PI, PID. So there you have seen that the PID controller is going to receive the input as an input signal, the error signal E of t. So the error signal is continuous in nature, so which is known as analog signal. So that's why many control applications do not involve analog process variables. So now we are going to understand where you will find that the some control applications are there which is not dealing with the continuous analog process variables. What is analog process control process variables? That is ones which can assume a continuous range of values. Instead of that variables that are set valued, that is they only assume values belonging to a finite set. So instead of this continuous or analog process variable, some control application we will find that they are going to assume the set valued functions. What is set valued? They are going to choose the input value as well as the output values from a finite set. The simplest example of such variables are binary variables that can have either two possible values such as 1 or 0, on or off, open or closed, etc. This control system operate by turning on and off switches, motors, valve and other devices in response to operating conditions as a function of time. Such systems are referred to as sequence or logic control system. So already in process control engineering you have seen one set of control algorithms which is continuous in nature. Now we are going to understand a control logic which is sequenced or logic control system. Now, typically the control problem is to cause or prevent occurrence of particular values of output process variables, particular values of output obeying time restrictions, given sequence of discrete outputs, given orders between various discrete outputs. So this sequence or logic control are going to handle this kind of control problems where you will see that we want a particular value of the process variable, or we want to restrict the output timing. Means suppose we want that some light is going to glow only for 5 seconds, or some motor is going to run for 3 seconds and after that it is going to stop. So time restrictions are there. Then given sequence of discrete outputs, it may happen that a sequence of discrete output is going to be repeat. So to handle this kind of situation we need logic control system, or which is known as sequence control system. And also given orders between various discrete outputs, it may happen that a sequence of operations and which is in a particular order has to be executed, and then we need a special control system which is known as sequence or logic control system. In industry, many manufacturing processes demand a sequence of operation which are to be performed repeatedly. Just now I told about that one. Early automation system were mechanical in design, timing and sequencing being affected by gears and cams. Slowly, this design concept were replaced by electrical relays. The relay provided many benefits since its operations were well understood. It was immune to electrical interference and able to handle typical industrial input and output signal without special interfacing. So initially this sequence or logic systems were performed by electrical relays. Now the sequence of control processes are given, the example has been given like a bottle filling plant. You can see that sequence controls are required for processes that demand certain operation to be performed in special order. What is the order? Now first, you see the sequence of bottles are coming, the filling and capping operations are the task has to be performed. First, you have to fill the bottle and then press a cap on it. So this task must be performed in a proper order. So like this kind of situation, if you want to handle, then the sequence control or logic control system is going to help. And initially this kind of control system was performed using electrical relays. Now here one comparison has been drawn in between the logics or sequence control and analog control. If you consider with respect to model, then you will find that the logic or sequence, for the logic and sequence control, we will use the logical state transition diagram to represent it. Maybe in your digital electronics, during the design of counter, you have seen that how the state transition diagram was helpful. But in case of analog control, you will find that the model is numerical and the modeling has to be done either by the differential equation or the difference equation. Fine. Then with respect to complexity, you will find that the logic or sequence control having simple model, easy to build, but in case of analog control, the model is complex and hard to build, and modeling is infrequent in case of logic or sequence control operation. It is not required all the times, but for the analog control, it depends on the situation that because in case of analog control, it is required to model the system. So in case of signals, the signal range and status, if you consider, in case of logic it is sequenced or timed, and in case of signal value, in case of analog control, that is function of time and it is going to be continuous, means the evolution of the system trajectory you have to consider. In case of control redesign or tuning, if you see, in case of logic or sequence control, it is on off or logical. In case of analog control, it is linear or non-linear analog. For the logic control, the control is supervisory. For analog control, it is automatic. And the logic or sequence control may be open loop, closed loop. For the analog control also it may be open loop, closed loop. For the control redesign or tuning is not required in case of logic and sequence control, which is infrequent, but in case of analog control, tuning is required. So these are the comparison in between logic and sequence control with analog controller. Now the programmable logic controller, here a typical figure has been depicted which is representing the PLC module, a modern controller device which extensively used for sequence control today in robotics, process control and many other automated system is the programmable logic controller. In essence, a PLC is a special purpose industrial microprocessor based real-time computing system which performs the following function in the context of industrial operation. What are they? In monitoring the input or sensors, execute logic, sequencing, timing, counting function for control or diagnostics, drives, actuators and indicators, communicate with other computers. So these are the typical job will be performed by a industrial PLC, programmable logic control system. The programmable logic controllers, which is also known as PLCs, are also referred to as programmable controllers, are in the computer family. They are used in commercial and industrial applications. PLC monitor inputs, you see here several inputs are there. It may be the photo sensor and or maybe the start stop switches. So PLC monitors the inputs and the status of the inputs goes to the PLC, and inside the PLC the user will write the suitable program based on which it makes the decision based on the program what it is written and control the outputs to automate a process machine. So it is based on the program logic. It is going to on off the pump, it is going to on or off the motors, it is going to on or off the lights. So this course is meant to supply you with basic information on the functions as well as the configuration of the PLC. So immediate after this we are going to understand the configuration of PLCs, and slowly we are going to understand about the functions of PLCs. Now, programmable logic controller having several advantages. It is easy to use to simple modular assembly and connections. You will find that all the components of the PLCs exist in a modular fashion, and if it exists in a modular fashion, then modular expansion capacity of the input, outputs and memory are possible. Means suppose initially you have purchased a PLC with 8 input and 8 outputs. Later on you thought that the input has to be increased by 16 and also the output has to be increased, so you can increase it by purchasing another module which is compatible with the PLC what you have purchased. Also the expansion of the memory is also possible. Simple programming environments and the use of standardized task libraries and debugging aids. So when we will learn the PLC programming, you will find that to understand the PLC programming, someone need not to be a very good programmer or the computer engineer. A layman can understand the programming environment of the PLC. Communication capability with other programmable controllers and computers are also possible with the PLC. How the evolution of the PLC has occurred. Before the advent of microprocessor, industrial logic and sequence control used to be performed using elaborate control panels containing electromechanical or solid state relays, contractors and switches, indicator lamps, mechanical or electronic timers and counter, etc., all hardwired by complex and elaborate wiring. And this is the typical picture of an electromechanical relay. Later on we will try to understand what is the mechanism is performed by the electromechanical relay. Here you can see that a big coils are there, and this is the contact, okay, and it is connected with a spring. So typical mechanism here, so this is the contacts, okay, and this is the spring, and this is a big coil you can see. So later on we will try to understand how the operation of the electromechanical relays are. Now, what are the limitations of these relays which is used earlier development of programmable logic controllers? Now, the relay does not have having multiple number of limitations. What are they? It suffers from contract wear and reliability problem. Being a single input multi-output, it is often completely unsuited for controlling in industrial processes. The relays are hardware, that is, relays are wired to perform a specific function, and when the system requires any change, the relays have to be rewired. So permanently actually relays are hardware. So now if you want to change your programming, then again the relays has to be hardware. Hardware system were very expensive to produce due to the high labor content, and the modifications were both difficult and time consuming. So a typical figure you can see where the electromechanical relays are used, which is look very clumsy, but in contrast to that, if you see the panel of a PLC of the modern days, then you will find that how neat and clean it is, which is very useful for the debugging also. Now, advantages of PLC. However, the development of microprocessor in the early 1980s quickly led to the development of the PLCs, which had significant advantages over conventional control panels. What are they? Programming the PLC is easier than wiring physical components. The only wiring required is that of connecting the IO terminal. So when we will learn the components of the PLCs, at that time you will see that with the PLCs only input modules and output modules will be connected by wiring, but the internal coils and contacts are not required to be connected physically. So all the contacts and coils will be available in the memory of the PLC. The PLC can be reprogrammed using user-friendly programming devices. Control must be physically rewired. So in case of PLC programming, you will find that some user-friendly programming methodology we will use, which is very convenient to understand. PLCs take up much less space. Already we have seen that one due to the advancement of the ICs. Installation and maintenance of PLC are easier, and with present day solid state technology, reliability is greater. The PLC can be connected to a distributed plant automation system, supervised and monitored. Beyond a certain size and complexity of the process, a PLC-based system compare favorably with the control panels. Ability of PLC is to accept digital data in serial, parallel, network modes imply a drastic reduction in plant sensor and actuators wiring, since single cable runs to remote terminal IO units can be made. Wiring only needs to be made locally from that point, so it can significantly save the wiring. Special diagnostic and maintenance modes for quick troubleshooting and servicing without disrupting the plant operations are possible, because here all the components of the PLCs are present by modules. So now some salient advantages we will recap, that is less hardware. If you see the relay control panel and PLC control panel, you can see that elimination of the hardware associated with the conventional relay control units or circuits are possible in PLC. The flexibility also you will get in PLC. What is that? In the past, each different electronically controlled production machine require its own controller. So 15 machine might require 15 different controller. But nowadays, now it is possible with to use just one model of PLC to run any one of the 15 machines, eliminate much of the hardwaring, and was associated with conventional relay control circuits, which is associated with the conventional this wiring, hard wiring. So now you see the many, depending on the capability of input module and output module, you can connect many inputs directly to the PLC and many outputs directly to the PLC, and which can be supervised by HMI software or the special purpose computer, and you can write the or you can interface the PLC to write the programming with the programming monitor, that is PC. It is easier to create and change a program in a PLC than to wear and rewire a circuit. So here you see only the physically you will find that the inputs are connected. So these are the inputs which will be connected with the PLC. But the actual programs you are writing inside the memory of the PLC, where the contacts are representing the inputs and the coil is representing the output. So now depending on the programming logic, whenever the output will be energized or de-energized, depending on that it is going to energize or de-energize the output. So that's why even if you want to change the programming logic, it is very easier, because no hardwaring is required, which was in the conventional or old technology, that is electromechanical relay driven control logic. Increased reliability. The PLC has a large number of contacts for each coil available in its programming. Means here you see, if this is the coil representing the output, then a huge number of contacts you can use to develop the programming. Suppose that panel where relay has 4 contacts and all are in use, when a design change requiring 3 more contacts is made, time would have to be taken to procure and install a new relay. So suppose you have developed, for example, here 3 contacts you have used. So in case of panel wire relay, if you require another 3, then again you have to procure and then you have to rewire with the system, so which require a lot of time as well as lot of investment. But in PLC, the number of contacts are limited by only the computer memory. So if you increase the memory, you can have more number of contacts, and anytime you can use to develop or modify your programming. Since all the logic is contained in the PLC's memory, there is no chance of making a logic varying error. With a wired relay type panel, any program alternation require time for rewiring of panels and devices, that already I have discussed. Where a PLC program circuit or sequence design change is made, the PLC program can be changed from a keyboard sequence in a matter of minutes. No rewiring is required for PLC control system. Also, a programming error occur has to be corrected in a PLC control ladder diagram. A change can be typed in quickly. Means even if you want to debug your programming, which is very easy, only you have to retype. Definitely the cost is lower because lot of wearing and time as well as money you are going to save. How the increased technology makes it possible to condense more functions into the smaller and less expensive packages in PLC. PLC can be purchased with numerous relays, timers and counters and sequencers and other functions with $100. Pilot running facility is there. What is that? Now, a PLC program circuit can be pre-run and evaluated in the office or lab. The program can be typed in, tested, observed and modified if needed, saving valuable factory time. Visual observation is also a great advantage. A PLC circuit's operation can be seen during operation directly on the CRT scheme, means how each of the input are executed, you can see it visually by changing color. And it is easier to troubleshoot. To make and fix problem, users can display the control program on a monitor and watch it in real time as it executes. Speed of operation, that is also a very important features of the PLC. Relays can take an unacceptable amount of time to actuate. Operational speed for PLC program is very fast. The speed for PLC logic operation is determined by scan time, which is a matter of millisecond. Communication compatibility is there or capability is there. A PLC can communicate with other controllers or computer equipment to perform such functions as supervisory control, data gathering, monitoring devices and process parameters, and download and upload the program. Reliability and maintainability. Solid state devices are more reliable in general than the mechanical systems or relays and timers. Documentation is possible. An immediate printout of the true PLC circuit is available in minutes if required. Otherwise, in case of mechanical or electromechanical relay control panel, you require a blueprint, and somebody wants to know how the circuits are connected, then that detailed circuit diagram has to be seen. But in case of PLC, immediately if you want to know that how the programming has been done, you can see by taking the printout. Security, a PLC program cannot be changed if the PLC is properly locked and programmed. What are the application areas of PLC? The PLC logic controllers are suitable for a variety of automation tasks. They provide a simple and economic solution to many automation tasks as logic or sequence control, PID control and computing, coordination and communication, operator control and monitoring, plant startup and shutdown. These are the typical applications or work has to be performed by the PLC. Any manufacturing application that involves controlling repetitive discrete operations is a potential candidate for PLC uses. For example, machine tools, automatic assembly equipment, modeling and extrusion machinery, textile machinery, and automatic test equipment. And what are the industrial areas where the PLC is applied? Now, for the chemical or petrochemical industries, batch processes, pipeline control, weighing, mixing, finished product handling, water waste treatment plants, you will find that there are numerous applications of PLCs there. Metals, blast furnace, continuous casting, rolling mills, soaking pits, steel melting shop, you will find the application of PLCs. In manufacturing and machining industry, that material conveyors, cranes assembly, milling, grinding, boring, planting, welding, painting, modeling, casting, forming. Okay, all these applications you will find that PLC is present. So we will stop here, and next class we are going to understand that what are the components of the PLC and how they are connected. Thank you.